So we're going to look at molecular geometries. So we want to draw out the Lewis structure and then we'll look at the molecular geometry. So for NO2 we have 5 valence electrons for the nitrogen, 6 for each of the oxygens, and then we have an additional electron coming from that negative charge. So that gives us 18 electrons. Nitrogen has to go in the middle, and we bond our 2 oxygens to the nitrogen. That takes care of 4. So 18 minus 4 is going to give us 14. We satisfy the oxygens, so that uses up 12 electrons. So we're left with 2 electrons left, which means those 2 are a lone pair on the nitrogen. Now we have to make sure that center atom is satisfied. Well, this nitrogen only has 6 electrons around it, 4 in the bond and 2 in the lone pair. So that means we have a double bond. So we're going to remove a lone pair from one of the oxygens, it doesn't matter which one, and we're going to double bond it. So looking at the electron domains, we have 1, 2, 3 electron domains, which would make the electron domain trigonal planar. However, this lone pair of electrons here is going to force this bond between the oxygen, nitrogen, oxygen to come even closer. And so this shape is called bent, and the bond angle is less than 120 degrees. So it's trigonal planar, 120 degrees, but since we're forcing those oxygens closer together, it becomes less than 120 degrees. Looking at the next one, we have nitrogen and then 3 fluorines. So that would give us 26 valence electrons to show. So we have nitrogen bonded to 3 fluorines. Satisfy the fluorine first. That's 24 electrons, so you have 2 on the nitrogen. So the electron domain, 1, 2, 3, 4, would be tetrahedral. Because of this lone pair, though, it's going to force those 3 fluorines closer together. So the molecular geometry is trigonal pyramidal. The bond angle for tetrahedral is 109.5, but because of that lone pair forcing the fluorines closer together, it becomes less than 109.5. SF6, so you have 6 valence electrons from the sulfur, 7 for each of the fluorines, and that gives you a total of 48. Sulfur would go in the middle. You have 6 fluorines to put around. Satisfy the fluorines. And there uses all 48 of our electrons. So sulfur doesn't have a lone pair. So we have 6 electron domains. So this would be octahedral. It is on the back side of your handout. And the bond angles then from fluorine to sulfur to fluorine would be 90 degrees. All right, let's look at BF3. You have 3 valence electrons for the boron and then 7 for each of the fluorines, so that would make 24. Boron would go in the middle, 3 fluorines around it, and that uses up your 24. Remember, boron only needs 6 electrons to be satisfied, so it has an incomplete octet. So there's 3 electron domains. So it is trigonal planar, and is 120 degrees. So here, the last two examples we did, SF6 and BF3, the electron domain and the molecular geometry are the same because there's no lone pairs on those center atoms. All right, let's look at ZF4. So xenon has 8 valence electrons. All of our fluorines have 7, so that's a total of 36. Xenon is placed in the middle. You have 4 fluorines to go around. Satisfy your fluorines. And that uses 32 of your electrons. So you still have 4 electrons left, so they become lone pairs on the xenon. So we have 1, 2, 3, 4, 5, 6 electron domains. So the electron domain is octahedral, but because we have these lone pairs on the xenon, the electron domain and the molecular geometry are not the same. So this sort of situation is square planar. So you kind of see a square if you look at the fluorines, and they would all be in the same plane with the lone pairs going into the other 2 planes. The bond angle for that is still 90 degrees because you're forming that square, so the fluorine to fluorine is still going to be your 90 degrees. SF4 will be our last one here. Fluorine has 7 valence electrons, and then sulfur has 6, so that's a total of 34. Sulfur goes in the middle. We bond our 4 fluorines around. There we go. So we've used 32. That leaves 1 pair, or 2 electrons, 1 lone pair that the sulfur would then have. So that's 1, 2, 3, 4, 5 electron domains, which would make it trigonal bipyramidal. Because it has that 1 lone pair, though, it becomes a seesaw shape. And yes, that is the actual name of that geometry, seesaw. So if you think about a seesaw, you have the sulfur, it's got a fluorine coming off of it, and then fluorines this way as well with a lone pair way up here. So you have that seesaw, that bent seesaw shape. So the bond angles are going to be less than 120 degrees.